Assalamualaikum and hi everyone. I hope that all of you are in the best of health and ready for the first topic for the physics subject in matriculation. The title for the first topic is Physical Quantities and Measurement. This is the overview of the first topic. The first topic is divided into three subtopics. The first one is dimension of the physical quantities. The second one is the scalar and vectors. And the third one is the significant figures and uncertainties analysis. The third subtopic you will learn in your practical class. This is the learning outcome for the first subtopic, which is dimension of the physical quantities. At the end of this topic, students should be able to define the dimension, determine the dimension of the derived quantities, and verify the homogeneity of the equation using the dimensional analysis. What is dimension? So the dimension is defined as the technique or method which the physical quantity can be expressed in terms of combination of the basic quantities. It tells us about the nature of the physical quantity but do not give any idea about the magnitude of that physical quantity. We use the square bracket to represent the dimension symbol and put the symbol of physical quantity inside it. For example, we can denote the dimension of the length as the square bracket, and inside the bracket we put the symbol for length. If we want to denote the dimension for the time, we use the square bracket, and inside the square bracket we write down the symbol for time. Do take note that we can only put the symbol of physical quantity inside the square bracket, not the unit of the particular physical quantity. Table 1.1 shows the dimension of the basic quantities. For the mass, the dimension of mass is represented by capital letters of M. For the length, represented by the capital letters of L. The dimension for time is represented by the capital letters of T. And for the electric current, the symbol of electric current is I, but the dimension for the electric current is represented by the capital letters of A. For the temperature, where the symbol for temperature is capital letters of T, but the dimension symbol is represented by theta. And for the amount of substance, which is represented by the symbol of N, and also the dimension symbol for amount of substance is also capital letters of N. The dimension can be treated as algebraic quantities through the procedure called dimensional analysis. The use of dimensional analysis are to determine the SI unit of any physical quantities, to check the homogeneity or consistency of an equation using the principle of homogeneity, and to derive or construct a physical equation. The principle of homogeneity states that each term in the equation must have the same dimension, or dimension at the left-hand side of the equation is equal to the dimension at the right-hand side of the equation. Do take note that the dimension of the dimensionless constant is equal to 1, such as number 2. The dimension for the number 2 is equal to 1, or refractive index also equal to 1. The dimension cannot be added or subtract. The validity of an equation cannot be determined by the dimensional analysis. The validity of the equation can only be determined by experiment. But we can prove the validity of the equation using the dimensional analysis. This is also the thing that you need to take note before you use the dimension analysis, which is how to write down the dimension form of the equation, or we call it dimension equation. Okay, so first, if we have the equation that relate to the additional or subtraction, so the dimension equation can be written as the dimension of A is equal to the dimension of B, equal to the dimension of C, and equal to the dimension of D. For second example, if the equation given as A, which is equal to B times C divided by D, so we write down the dimension equation as the dimension for A is equal to the dimension for B times with the dimension for C divided by dimension for D. And if you have the equations such as A is equal to half BC square, so the dimension equation that we can write down is A, dimension for A is equal to dimension half times with the dimension for B times with the dimension for C square, or because of we know that dimension for half is equal to 1, we also can write down this equation as dimension for A equal to dimension for B times with dimension for C square. The second subtopic is to determine the dimension of the derived quantities. Actually, from the output of the dimension of the derived quantity, we can identify the SI unit for that derived quantity. So, to determine the dimension and also the SI unit for the derived quantities, first you need to write down the formula or equation for the derived quantity and change that formula into symbol. The second one, you can write down the dimension equation and then identify and substitute the dimension for each physics quantity in the equation, and then the dimension form of equation will guide us to find the SI unit. Do take note that we can skip step 1 if the physical quantity for the derived quantity is given. So you can write down directly the dimension equation if you know the equation for that physics quantity. To determine the dimension of the derived quantities, take a look at the example 1.1. So I explain one question which is to determine the dimension of the velocity. So first step is you write down the equation, the physics equation for the velocity, which is the velocity is equal to the change in displacement divided by the time interval. And then we write down the dimension equation where we put the symbol for each physical quantity inside the square bracket. And this bracket, for example, is represent the change in displacement where the dimension for the displacement is L and the dimension for time is T. Because of that, we get the dimension for the velocity is Lt minus 1. And if you refer to the table 1.1, you can identify the SI unit for velocity, which is L is the dimension for length, the unit is meter, and T is the dimension for time and the unit is second. So we get the SI unit for the velocity is meter per second. Okay, this is the example how to determine the dimension and the SI unit for the acceleration, for the linear momentum, for the density, and also for the force. To verify the homogeneity of equation using dimensional analysis, take a look at the example 1.2. In this example, you need to determine whether the following expression are homogeneous or not homogeneous. The solution in this example show clearly how to solve this question. First step, you need to write down the dimension equation and then identify the dimension at the left hand side of the equation. Then identify the dimension at the right hand side and compare the dimension at the left hand side and with the dimension at the right hand side. So if you get that the dimension at the left hand side is equal to the dimension at the right hand side, so we said that the equation is dimensionally correct or homogeneous. The step is also same for the solution for example 1.2b and 1.2c. Now you will learn the second subtopic, which is about the scalars and vectors. So at the end of this topic, you should be able to define scalar and vector quantities, resolve vector into two perpendicular components, which is x and y axis, and determine the resultant of the vector. So do take note that the resultant vector is only involved to maximum 3 vectors only. What is scalar and vector quantities? Scalar quantity is defined as the quantity with magnitude only. For example, mass, time, temperature, pressure, electric current, work, energy, power, and else. Mathematics operational is ordinary algebra. For the vector quantity, it is defined as a quantity with both magnitude and direction. The example is such as displacement, velocity, acceleration, force, and others. Vector can be represented by an arrow. The length of the arrow is represent the magnitude of the vector, and the direction of the arrow represent the direction of the vector. Table 1.2 show the written form or the written notation of vectors. We can use that form or that notation to represent the vector. Vector P and Q is said to be same in magnitude and direction. So we can write down the notation P, vector P is equal to vector Q. If we have a vector A, which is multiplied by a scalar quantity K, then the vector A is equal to Ka as shown. If K positive, meaning that the vector is in the same direction as a vector A, and if K is negative, the vector is in the opposite direction of vector A. The direction of vectors can be represented by using a few ways. The first one is the direction of compass, which is showing east, west, north, south, northeast, northwest, southeast, and southwest. Second way is angle with the reference lines. For example, referring to this figure, a boy throws a stone at a velocity of 20 meters per second, 50 degrees above the horizontal. By using the Cartesian coordinate, we can state the direction of a vector using 2 dimensions or in 3 dimensions. We also can state the direction of a vector using the polar coordinate as shown in the figure. And lastly, we can denote with the positive or negative sign. For the positive and negative sign, we follow this rule where if the x component of a vector is pointing to the right, then its x component is positive. If x component of a vector is pointing to the left, then its x component is negative. Same thing for the y component. If the direction of y component of a vector pointing upward, so the component is positive. And if the component is pointing downward, its y component is negative. To resolve the vector into two perpendicular components x and y axis, take a look at the first case. For the first case, theta is the angle between the r and rx. So to resolve the vector r, at x component, rx is equal to r cos theta, and at the y component, ry is equal to r sin theta. For the second case, the angle theta is between the r and ry. So for the resolving vector r at the x component, rx is equal to r sin theta, and at the y component, ry is equal to r cos theta. For first case and second case, it is a single vector. So for a single vector, to calculate the magnitude of the vector r, we will use the equation of r is equal to third rx square plus ry square. And because of vector quantity, we need to identify also the direction. So the direction of the vector r is equal to shift tangent ry over rx. If we have more than one vector, so to calculate the magnitude of the resultant vector, we need to sum all the vector at the x component and y component. Because of that, the magnitude of the resultant vector is equal to the sum of rx square plus r sum of ry square. And for the direction of the resultant vector, we will use the equation as shown. Example 1.3 will guide you how to sketch the resolving vector at the x component and y component, and also to show how to resolve vector A and vector B into x and y component. The last subtopic is to determine the resultant vector. Referring to the example 1.4, given f1, f2, and f3 as shown in the figure 1.3, determine the resultant vector f. Take a look at the solution. There are few steps that you can follow. The first step is you need to draw the x and y component for the vector f1, f2, and f3. After you draw or you sketch the x and y component of the vector f1, f2, and f3, you can calculate the magnitude of each component vector. To calculate the magnitude of each component vector, you also can refer to the example 1.3 for the resolving vector. The next step is you can calculate the sum of magnitude of the resultant vector at the x component and at the y component. After that, to calculate the magnitude and direction of the resultant vector, you can use the equation as shown. That's it for the first topic. So the next topic is topic 2 with the title of Kinematics of Linear Motion.